Welcome to the fifth lesson of the DevOps course. In this lesson we will learn about the fourth stage of DevOps, which is test. The testing stage is a critical component of the DevOps lifecycle, aimed at ensuring that the software product meets the desired quality and performance standards. Testing involves verifying that the software works as intended, and that it can handle various scenarios and user interactions. The testing stage is typically the fourth stage in the DevOps lifecycle, following the plan, develop, and build stages. During the testing stage, different types of tests are performed to detect defect, vulnerabilities, and performance issues in the software product. The types of tests that can be performed during the testing stage include unit testing, integration testing, system testing, acceptance testing, and regression testing. These tests help identify bugs, verify that the software meets user requirements, and ensure that the software functions correctly in different environments. The key tenets of the testing stage are finding the bugs or defect, establishing the process for testing, and last but not the least, choosing the right testing tools. In this lesson, we will delve deeper into the testing stage of the DevOps lifecycle. We will explore the importance of test planning, the process of test execution, and the significance of test reporting and analysis. We will also discuss how continuous testing can be integrated into the DevOps pipeline to ensure that testing is performed at every stage of the development process. Here are the different aspects you need to consider when designing your test plan. Objectives and scope. Clearly define the testing objectives and scope, including what functionality will be tested, what will not be tested, and what risks are being addressed. Identify the software requirements that will be validated during testing, and any regulatory or compliance requirements that must be met. Test types and techniques. Identify the types of tests that will be performed, such as functional, performance, security, or usability testing. Determine the testing techniques to be used, such as manual testing, automated testing, or exploratory testing. Establish test criteria for passing or failing each test, and the criteria for overall test success. Test environment and data. Specify the environment in which testing will take place, including hardware, software, and network configurations. Determine what test data will be required, and how it will be obtained, created, or generated. Testing schedule and resources. Establish a schedule for testing, including the start and end dates, testing phases, and milestones. Determine the resources needed for testing, including personnel, tools, equipment, and budget. Test deliverables and reporting. Define the test deliverables, such as test plans, test cases, test scripts, and test reports. Determine how test results will be reported, including the format, frequency, and audience for test reports. A comprehensive test plan is essential for ensuring high-quality software that meets requirements and is free of defect. A well-planned testing effort can help catch and resolve issues early in the development process, reducing costs and improving customer satisfaction. There are basically 7 types of tests. Unit testing. This type of testing involves testing individual units or components of the software application to ensure that they work correctly as per their design specifications. Unit testing is usually automated and carried out by developers themselves. Integration testing. Integration testing is the process of testing the interaction between different units or components of a software application to ensure that they work together as expected. This type of testing is usually carried out after unit testing and before system testing. System testing. System testing is the process of testing the entire software application to ensure that it meets its functional and non-functional requirements. This type of testing is usually carried out by a separate testing team. Acceptance testing. Acceptance testing is the process of testing the software application to ensure that it meets the requirements of the end user or customer. This type of testing is usually carried out by the end user or customer themselves, or a representative from their side. Performance testing. Performance testing is the process of testing the software application to ensure that it meets its performance requirements. This type of testing includes load testing, stress testing, and scalability testing. Security testing. Security testing is the process of testing the software application to ensure that it is secure and protected from external threats such as hackers, viruses, and malware. Regression testing. Regression testing is the process of testing the software application after making changes or updates to ensure that the changes did not introduce any new bugs or issues. Each of these test types serves a unique purpose in ensuring the quality and functionality of the software application. It's important to choose the appropriate test types based on the specific needs and requirements of the project. For continuous testing, it is important that right test frameworks based on the test type, the scale, and the test environment is selected and implemented. This will then become part of the DevOps pipeline, thus making the test process continuous. For unit testing, you can use Junit, Nunit testing, XC test for integration testing you can use. Selenium WebDriver, Appium, Test Complete. For system testing you can use. Selenium WebDriver, Appium, Test Complete. For acceptance testing you can use. Cucumber, Fitness, Selenium WebDriver. For performance testing you can use. Tuner, Load Runner, Gatling. For security testing you can use. OWASP App, Burp Suite, Nessus. For regression testing you can use. Selenium WebDriver, Test Complete, Appium. Note that these are just a few examples of test automation frameworks that can be used for each test type. There are many other tools and frameworks available in the market that can be used based on the specific needs and requirements of the project. Test reporting is the process of documenting and communicating the results of testing activities to stakeholders. It helps in providing visibility into the testing process, identifying defect, and tracking the progress of testing activities. There are two main types of test reports. Summary report provides an overview of the testing process and highlights key metrics such as test coverage, defect density, and pass/fail rates. It provides a high-level view of the testing activities, making it easy for stakeholders to understand the current state of the testing process. Detailed report provides a detailed analysis of test results, including test cases executed, defect found, and their severity. It provides a comprehensive view of the testing activities and enables stakeholders to dive deeper into the testing results. Both types of test reports play a crucial role in software testing as they provide valuable insights into the effectiveness and efficiency of the testing process. By analyzing test reports, stakeholders can identify potential risks and issues, track defect, and make informed decisions to improve the testing process. As part of the test reporting, the identified test metrics should also be published. The test metrics are quantitative measures that provide insight into the effectiveness and efficiency of the testing process. The different types of test metrics that can be defined are test coverage, test execution, defect density, pass/fail rates, and others. All the different types of tests that are defined as part of the testing process and executed through test automation needs to be tracked. Thus, the test tracking is the process of monitoring and controlling the progress of testing activities. Test tracking helps in identifying potential risks and issues, tracking defect, and ensuring that testing activities are completed within the allocated time frame. There are various test tracking tools that can be used as part of the process. You have successfully completed Lesson 5 of the DevOps course. In the next lesson, we will deep dive into the fifth stage of the DevOps lifecycle,